What happens when you add a constant to each of the scores in your sample? Let me give you an example here that'll help make sense of what I mean by adding a constant to the scores. Let's say, for example, you have baked a bunch of cookies, and so you've left a big tray of cookies out, and there are 1, 2, 3, 4, 5 different people at your party, and you keep track of how many cookies they casually come up and eat. So one person took only 2 cookies, whereas maybe these 2 people here took quite a bit. This guy took 10 cookies off the tray. Okay, so you can work out what the average is. What's the average number of cookies that people took from the tray? So I would have to add these up to get my total, and then I can find my sample mean. So let's do that. 2 plus 3 is 5, plus 7 is 12, plus 8 brings me to 20, and another 10, that brings me to 30. So I've got 30 over 5 people telling me that on average, people took 6 cookies from the tray. But what if I didn't want to know just how many cookies did people take from the tray? Let's say that I also had given everybody a doggy bag with 3 cookies to take home. So that increases the number of cookies that each person has had by 3, no matter what they took in the first place. So all of these numbers get bumped up by the same amount. That's what a constant is. That's what they mean when they talk about adding a constant to your scores. So I'm going to add the same number to all of these scores, this constant number 3. So 2 plus 3, that's going to give me 5. 3 plus 3, that's going to give me 6. 7 plus 3 will give me 10, and so on. So this is my new data. This is the number of cookies, including the doggy bag. Okay, so if I wanted to know what my mean was here, the new mean after this has happened, I could sum everything up. So let's do that. 5 plus 6 is 11, plus 10 brings me to 21. This brings me to 32, and this brings me to 32 and 45. So I'm going to have now the sum of x over n is going to be 45 over, it's still the same number of people, so it's still over 5, and so this comes out to be 9. So this is the long way of doing it, but it's not difficult. It's exactly what we did the first time we had to work out the mean. But there is a shortcut. If you've already done the work and figured out the mean, and then you know that you're going to be adding a constant to all of your data, the same thing to every single score in your sample, all that you have to do to get from the new mean, or from the old mean to the new mean, is just add that same constant. So if you, actually let's make that a little bit easier to see. We can put it this way. If we add a constant to our scores, then the mean also increases by this constant. So if I had added 10 to each of my scores, then the mean would have been 10 higher. Instead of being 6, it would have been 16. If I added 100 to each of my scores, instead of having a mean of 6, I would have had a mean of 106. Now, we can generalize this too beyond just addition. Instead of if we add, it could be if we add or subtract a constant to our scores or from our scores. So actually, let me rewrite this. Let me say that if each score changes by a constant amount, So that includes adding a constant or subtracting a constant. So either I'm going to subtract 5 from all of these, or I'm going to add 3 to all of these, and so on. So if each score changes by a constant amount, then the mean changes by that same constant amount. Okay, so that one is generalized now to addition and subtraction. So the example, we just did addition, but if you had gone through and you had subtracted 3 from all of these, you would have found, or from all of these, you would have found that you could apply this one. We would have gone from a mean of 6 down to a mean of just 3 if we had subtracted 3 from all of these.